So, um, you can kind of watch what happens here. Um, remember, slope is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Okay? Now, I want you to understand something how we generate this. What was the point, P, that we were trying to find the slope at? 1, 2 was the point. Okay? Now, point Q, did the x value stay the same or did it change? It changed. So we'll call the x value x. What did we do to generate the y value? We plugged it in. X squared, what was it? Plus 1. I've never done this before, but I'm going to show you the beauty right away. After I show you the beauty, you have to go back to the real world, okay? So I'm going to jump ahead. You got to come back, okay? But you can live in both worlds, but you got to make sure that you live in the now. Can you live in the now? Okay. So what we said is this. Look, we're going to use this term, the limit. The limit is what we're going to cover really probably tomorrow or Monday. It's this idea that we're approaching. So the limit as, yeah, so from, that happens every year. In fact, I was flipping through channels the other night and I saw Mean Girls on. I was like, oh, I'm going to watch it. Because I've never actually watched it. But every time I say limit, somebody says, does not exist. And I'll teach you guys about limits that don't exist. I will. I'll teach you about limits that don't exist. I'll teach you that on Monday and Tuesday next week. We'll watch the clip. We'll bring back Katie Williamson. She will rap. Have you seen her do the Kevin rap? Oh, my goodness. That girl, unbelievable. In fact, she made a video, and I think we will find it truly amazing. So this says that Q approaches P. Okay, so the limit is Q approaches P of M is equal to this. So M is the slope. Watch this, okay? Watch where I get this. What is y sub 2 here? X squared plus 1 minus, what is y sub 1? 2 divided by, what's x sub 2? X minus 1. Would you agree that that represents the slope? Watch what happens. How many points again do we have? 1. What is x squared plus 1 minus 2? Divided by? Can you divide those? Does the top factor? Top factor is to x plus 1 times x minus 1 divided by x minus 1. What happens? What are you left with? Look at this. How close do you want to slide Q to P? All the way on top of it, right? So that Q would eventually have a value of, plug in 1. It's 1 plus 1. 2. That's the slope. Watch again. Watch again. Watch again. You want to slide Q close to P, right? So that the x value of Q will become the x value of P. All right? When we do that, we come up with an expression of x plus 1. What did our x value become? Plug it in. 1 plus 1 is? What was the slope of our line yesterday? So it won't always work out like that where you could do the algebra. It won't always divide out. But it is really cool. What I want you to write basically right here is, what this means is the closer Q is to P, the closer the secant line, slope of the secant line is to the tangent line. So I was able to do some algebra here. This algebra meant that we did not have to do this anymore. We didn't have to come real close to it. We could just simply plug it in. It doesn't always work like that, though. I showed you a real nice example. So instead of jumping ahead to where that's the real nice world that we want to be in someday, we're going to go back to reality for something that wouldn't work out. And we're going to look at an example here where we wanted, this is what you're going to be asked to do for your assignment. So this is a problem almost identical to one that's out of your book. And it says, the point P, 3, 2, lies on the curve y equals x plus 1. First of all, I want to verify, does that point for sure lie on that line or on that curve? If you plug 3 in for x, you get square root of 4, which is 2. So, yep, it works out. So here's what I want to do. It says if Q is the point x, comma, square root of x plus 1, use your calculator to find the slope of the secant line PQ, correct to 6 decimal places. You guys have, do you have a blank page on the back side of your notes? Okay, let's draw the shape there, okay? What does the square root of x plus 1 look like? Well, I know your pre-calculus teacher from last year, and I know that he did teach you this. I don't know how good of a teacher he was, but I do know he taught you this. So square root of x plus 1 goes which direction? Right or left? Right. Does it go up or down? Up. And is it shifted 1 unit to the left or 1 unit to the right? Shifted 1 unit to the left. So this is the graph of the square root of x plus 1. If you do not know what the graph looks like, you're going to have to draw it on your calculator and be able to go from there. Go into mode and switch from parametric form to function form. So this is the spot that we're looking at, okay? So your book is not always going to give you the visual. So what I'm trying to do right now is draw you a visual so you can kind of understand what's happening, okay? This is the tangent line, okay? This is point P. What's the other point we're using? Q. Now, Q could be in front of it. Q could be behind it. It doesn't matter. It does not matter. Can you live with that? That doesn't matter? So for just the sake of being easier, I'm going to put it behind it, okay? I'm going to put that as point Q. True or false? The x value of Q changes. True. So I'm going to call the x value x. What do I get when I plug in the y value? Square root of x plus 1. Okay? So I have how many points now? 2 points. I don't really have, I have a point that constantly changes, but I do have 2 points here, okay? So let's write a formula for slope, okay? M equals, what's y sub 2? Square root of x plus 1. Minus 2. All over x minus 3. The reason why I'm showing you this is because it's going to be easier for you to calculate this, plug it into your calculator, than simply doing it manually all the time. So if you want to go back and plug in these points, go ahead. It says calculate 4, calculate 2.5, 2.99, 3.0001. If you want to go back here and figure out, well, what would the x and y value be, and then use your slope formula, fine. Or you can do the shortcut. And the shortcut is take out your calculator. And we go into y equals, and I type in my slope formula. Slope formula is parentheses, what? Square root of x plus 1. Everybody see that? You get out of T by going into mode, go down to function instead of polar. Now, you don't have to graph it. All you have to do is go second table. And let's see what happens when we go to our table. It says, so let's go back to the question. We set it all up. If Q is the point, which we've established, use your calculator to find the slope of the secant line PQ, correct to 6 decimal places for the following values of x. So instead of, plugging in 4 to the function, writing them down, using your slope formula, they're all plugged in here right now. So what do I have to plug in? 4. If I plug in 4, I get 0.23607. Yep, so we'll go to 5 decimal places. Thank you, Megan Stark. Is that the slope of the tangent line or the secant line? Secant line. I plug in 2.5. Get 0.2583. I know it's a secant line because the tangent line would have an x value of 3. Tangent line would have an x value of 3. And we'll get to that in a second, okay? So here we go. I punch in 2.999. Just 3 nines, not 4. And I get 0.25002. Does anybody want to guess what the slope is getting closer towards? Yeah, 0.25 or 1/4. So now I go 3.0001. And I get, it says 0.25. That it's rounding, and that's just where it gets. Now, again, these are secant lines because we have a value different than 3. What happens if we plug in 3? Why? What would you be dividing by? You'd be dividing by 0, so therefore you can't do it just in one spot. Your calculator can't do it. Now, I showed you a way out of that problem up here where we were able to divide out and it wasn't an issue. But here, it's a big problem, okay? All right, so use the results of part A. Guess the value of the slope of the tangent line to the curve at 3, 2. What do you think it is? I would agree. I think 1/4 is a great guess. We have not confirmed that it is exactly 0.25. I will tell you that it is 0.25. We haven't confirmed it. We have a lot of data that suggests it is. That's what we're going to roll it. Using the slope from part B, find an equation for a line tangent. So I now want to find the equation for this line right here in red. In order to find an equation for a line, I have to what? Have what? Slope and point on the line. What is the point on the line that the tangent line passes through? 3, 2. Okay? So I have y equals mx plus b. I have 2 is equal to 3/4 then plus b, or 8/4 is equal to 3/4 plus b. Subtract over, I get 5/4 is equal to b. Or my equation is y equals 1/4 x plus 5 over 4. Now I'm going to show you the coolest part. Take out your calculator. Go down to y sub 2. We won't erase stuff in y sub 1. You will type in the square root of x plus 1, which is our function. Whoop. And down below it, we'll type in the equation for the tangent line, which is 0.25x plus 1.25. And I'm going to go up to that top function and take it off so that I don't see it. I'm going to view it in a standard window, zoom 6. As you can see, it graphs the radical, and then what do you notice about that line? It is, what do you notice about the line? It's tangent. Hey, how long would it take you to, like, type in different lines and finally come up with one that was perfectly tangent? I mean, that line is perfectly tangent to that curve at the spot 3, 2. And you could zoom in on it and you'd see that it just touches just one spot. And that's pretty cool. So I want you guys to practice just these type of problems before we move on. We're going to go slow through this first lesson. But first, you're going to need your books. So I'm going to have you guys come up, and you're going to grab a book. I'm going to write down your number, and then I'm going to ask you guys to start a couple problems from your book that are about this exact type of thing. Can you do this type of problem? Okay, so you could get your homework assignment out, okay, or your notebook out. Just let's have January through March birthdays come on up first, okay, and you can grab a book. Okay, so all I'd like you to do is that exact problem we just did. You're going to see 3 problems basically just like that. Problems 3, 4, and 9. You're going to have the rest of the hour to work on it. We're not going to move forward. Tomorrow we'll finish off these notes, and you'll get an extension from this assignment. So here's what I'm going to do. Your books, just so everybody's clear, your books that you have in front of you, most of them should have a number on the inside, like Tyler says 08. If yours doesn't, don't worry. I'll get that figured out, but it should have a number right on the inside. I'll come and get it. Now, we do have about a dozen calc books left over. So that means if you want to share with a group of 2 or 3, we would be able to have a classroom set. But if you want to make sure you have your own, you got to bring it each day. Otherwise, you will be able to leave these at home. The rest should be a classroom set. Got it? So I'm not going to have the classroom set up there. It's just too much congestion in that area. Your books will always be up here. This is calculus's table. That's pre-calculus's table. Your answer books are over there. Sometimes people refer to this as the Calculus Bible. There's 3 of them over there. They're all the same translation. So you can check those out. But please, you guys, I do ask you this. Please make sure that when you use the books that you return them each day to that spot. Because I hate going around and picking everything up, okay? So I'm going to come around and get your number. Just start on those 3 problems. You have the rest of the hour to work. Enjoy that time to get some of your homework done. Before you ask a question about math induction or sequences or series, please do at least problem 3. Again, this is the learning process. You learned it. Now you need to practice it, put it on the work table, and then tonight you need to sleep. And when that happens, it converts to long-term memory. That's how it works.